BMS SIS Burner Management System (BMS) options used in process industry for heaters, furnaces, and boilers. These systems are typically installed to prevent accumulation of gases in the firebox, as well as protecting significant asset and business interruption losses. The BMS SIS can be installed on heaters, furnace, and boilers application. Our design fulfills the requirements of the following standards: NFPA 85 for single and multiple burner boilers, NFPA 86 for furnaces, and API 556 for heaters. The ISA Technical Report TR840005 for identification of safety instrument function in BMSs. One of our BMS SIS solutions for heaters, furnaces, and boiler is the heater protection system. This system is designed to provide a safety function to mitigate hazardous events on pilot, main burner headers, and fireboxes. For example, the heater protection system will allocate the safety functions to shut down the pilot system based on high or low pilot gas pressure, shut down the main burner header based on high or low fuel gas pressure or low pass flow. The system will also provide maintenance bypass capabilities by using bypass key switches for each of the functions or group of functions, and provide manual shutdown capabilities as a compensating measure and local reset commands to open the pilot valves and main burner valves. Here we have an overview drawing representing a BMS SIS heater protection system with 6 safety functions, typically found on refinery process heaters. The system is powered with redundant 120-volt AC, so this panel has an internal redundant 24-volt DC power supply. We have a 2 out of 3 volting configurations for the high or low fuel gas pressure to trip the main burners, a single transmitter for high or low natural gas pressure to trip the pilots, 2 heater pass flow. Each of the passes is being protected by a 2 out of 2 volting low flow to trip the main burner, a local and remote heater shutdown commands to trip both pilots and main burners, maintenance bypasses key switches for each process variable with local indication, the local reset commands to open the pilots and main burner independently, and hardwire or serial communication to the BPCS for alarm indication. Another BMS SIS solution for heaters, furnaces, and boiler is the BMS system. This system is designed to have the same safety functions that a heater protection system will provide, but the BMS solution will also include the following sequences: air or nitrogen validation for purging the firebox, pilot light off and main burner light off with the appropriate permissives and sequences. And finally, our BMS SIS Smart BMS solutions for heaters, furnaces, and boilers. This system is the same BMS with smart capabilities like Human-Machine Interface (HMI) to display a process overview, permissive graphics, software maintenance bypasses, trip reset, and light-off commands, as well as alarms and first-out trips. Also, this system includes diagnostic capabilities to perform deviation and command disagree alarms, transmitter failure, BMS sequence interrupt, and first-out alarms. Enhanced communication capabilities with the BPCS via Modbus, Ethernet, or even wireless. Here we have an overview drawing representing a BMS SIS Smart BMS solutions for heaters. This is again basically the same heater protection systems with the following modifications: include nitrogen or an airflow function to validate the purge sequence, include permissive safety functions to confirm the natural gas and fuel gas valves are closed during purge validation and light-off sequences. The maintenance bypass key switches are being replaced by one bypass-enabled switch. This switch provides the permissive to set the software maintenance bypass per each function. HMI with permissive pages, process overview, diagnostics, maintenance bypasses, and alarms. Here we have an overview drawing representing a BMS SIS Smart BMS solution for a boiler application. This solution manages the light-off sequence including purge validation, pilot, and main burner light-off. The differences here is the safety function types or counts. We have on boiler application flame detection, drum level, firebox pressure, and other safety functions to shut down the pellets and main burners. We can see here a solution comparison between heater protection and the smart BMS systems. On the heater protection system, we have local key switches for maintenance bypasses, but on smart BMS solutions, we have one enabled key switch and soft maintenance bypasses via HMI. We have sequence and alarm indication via local panel lights on the heater protection solutions, but we have the same alarm plus diagnostics alarms available via HMI graphics. For the heater protection system, the logic reset and sequence commands are installed on the front panel using push buttons. On the smart BMS, all these commands are available via HMI. The heater protection panel do not have diagnostic capabilities. The user will have to configure this on the BPCS. But instead, the smart BMS is designed to provide full diagnostic, including deviation alarm, transmitter failure, first out trips, command disagree, detailed BMS sequence interrupt alarm, and process overview graphics. There are many ways to implement BMSs. According with our experience, we believe the customer should maintain the following field and system requirements. The design should be individual standalone system, applying one system to each heater, boiler, or furnaces. Placing multiple heaters in one SIS will complicate devices, SIS maintenance, and testing. Performance of one SIS will impact all operating heaters, and there are some local panel requirements for heater operations. So one of the options the customer has is implement the BMS in a PLC. Well, we have done cost comparison analysis to demonstrate that PLC are not cost effective when we have an application with a small I/O, less than 12 analog inputs. Also, the design will require programming, software support, and engineering station even for simple functions. Additional requirements for field installation, like significant field wiring, remote instrument enclosure to allocate processor and I/O modules, plus the local panel requirements for heater operations. Another solution is to use a Diamond SIS system, where the cost of dedicated system is less than the hardware cost for a single PLC to handle multiple heaters. Simple electrical system can be supported by a qualified electrician. There are not software requirements to achieve safety. With individual SISs, each heater, boiler, or furnace can be operated, inspected, maintained, and tested independently. There are not common cause of failures between functions or heaters, and the system is ready to be installed in the field for heater operation, so not remote instrument enclosure or major wiring is required. More information about this system can be found in the specific brochures, which contain a guideline on how to order the systems.